right, so we have, not this one, hold on. There we go. So remember, on the last example we did, we had the absolute value of 3x minus 4 is equal to 11, and we had to do equal to the positive 11, equal to the negative 11. Well, when it's greater than or equal to, the greater than, we have to do the same thing. We're going to do it greater than or equal to positive. When it's greater than, it's or, which is the union. 3x minus 4, we have to reverse the sign. We have to reverse, when I say reverse the sign, I mean, sorry, we have to reverse the symbol, and we have to reverse the sign of the 11. So we've got to reverse this, we've got to reverse that, okay? So we're going to add 4. We have 3x is greater than or equal to 15, or x is greater than or equal to 5. So that goes this direction. We're going to add 4. And we have x is less than or equal to negative 7/3. Now with negative 7/3, we are, it goes in there twice. I need to stop working when I'm tired. There we go. Okay, that's a 6. So it's a little bit beyond negative 2, and it's less than or equal to. All right. So negative 7/3. Now, union, or, it means take both of them. Negative 7/3 and 5. So when we do our interval notation, we have to have 2 intervals separated with the union symbol. So my first interval over here, negative infinity to negative 7/3, union, and then this interval over here, 5 to infinity. All right, and then we're going to do one more time. This time it's going to be less than or equal to, which is and, which is the intersection. And it's kind of nice because I'm awfully positive I didn't spell that correctly. I'm so tired. Okay, so and the intersection, right? But we can write it as a 3-part inequality, as I was saying in the last video. So we're going to take our negative 11 right here, and then less than or equal to, we're going to put the inequality in the middle, or the absolute value in the middle, and then our less than or equal to, and then the positive, okay? All right, good thing this is the last video of the evening. Oh, goodness. And we're going to divide by 3. And so we have is less than or equal to x is less than or equal to 5. So we notice you have your 5 in between these two numbers. So we don't technically need to do 2. We don't technically need to do 3 number lines. We can just we just know how to graph this with the shading in between these two numbers. And my interval notation is going to look like that. All right. So this one, this is a greater than or equal to, that's or. So 20 minus 2x, or we can't write this one as compound inequality, or 3-part inequality, doesn't work. Less than or equal to negative 20. So reverse the sign and or reverse the symbol. So we're going to subtract 20 divide by -2. Doesn't matter that this is 0. We still have to reverse the symbol. X is less than or equal to 0. So that's going to go in this direction. Subtract the 20. Reverse the symbol. Don't forget, we're dividing by a negative. So here is my 20. And remember, OR is the union. So I need both of these intervals. And over here, and my interval notation, I kind of ran out of room here. -infinity to 0. Union 20 to infinity. Okay, now here is something super duper important right here. You cannot set it equal to the positive and negative when there is a number or anything outside of the absolute value on the same side. So what we have to do, we have to get rid of the 4 first. You have to get rid of the 4 first. You have to get rid of the 4 first. One more time. You have to get rid of the 4 first. Once we have the 4 on the other side, then, only then, can we set it equal to the positive and set it equal to the negative. Okay? And then we're just going to subtract 2. And we get almost always you're going to end up with one of the numbers as a fraction, even though we try really hard to make nice numbers as answers. Absolute values, it's just almost impossible. This is a 3, by the way. It doesn't look like a 3, but it is. Okay, same idea. We have to add the 3 first. Greater than, that's an OR situation. Reverse the symbol, reverse the sign. Reverse the symbol, reverse the sign. OR. All right, so we've got greater than 0. We've got less than -4. And I need both of them. Where's my 0? -4, union, 0 to infinity. This isn't the same one, is it? It's greater. No, this is less than. So absolute value is less than 2. Less than, we can do it as our 3-part. Okay, our negative on the left, positive on the right. Don't forget, when you subtract the 2, you have to subtract it in all 3 places. And we don't need 3 different number lines, not when it is between. So my -4, my 0, and my interval would look like -4 to 0, like that. Okay. Now, when we have an absolute value equal to an absolute value, we still have to set it equal to the positive. We still have to set it equal to the negative. Be really super careful when you set it equal to the negative to put that in parentheses. Super important. So we are going to set it equal to the positive. And we're going to set it equal to the negative in parentheses. So subtract our 3x, add 1, you get 6, distribute the negative. Don't forget to distribute the negative to the 5. Add 3x. Add 1. And divide by 7. All right. Okay, some special circumstances here. The absolute value of an expression can never be negative. The absolute value has to be greater than or equal to 0. Has to be greater than or equal to 0. Has to be greater than or equal to 0. The absolute value of an expression equals 0 only when the expression itself is equal to 0. So this, see where it says the absolute value is equal to a negative number? This is a distance. Distance can't be negative. No solution. This one, normally we would set this equal to a positive and a negative when we take away the absolute value, but there's no such thing as a positive 0 or a negative 0. It's just 0. So 1/4 x minus 3 is equal to 0. Absolute value, when it equals 0, we just have the equal to 0 part. There's no plus or minus. Multiply by 4, and you get 12. This one's kind of tricky. Let me show you what's happening here. We have the absolute value is greater than -1. The distance has to be greater than -1. Okay, so here's my -1, right? But remember, you can't have a negative absolute value. So it has to be greater than 0. Okay? There's no way for the distance to be negative. So we've got x has to be greater than 0. 0 to infinity. On a number line like that. X minus 10. Remember, we have to add the 2. We cannot have an absolute value smaller than 0. In fact, it certainly can't be smaller than -1. So this is going to be a no solution again. Yeah, this just doesn't work. We can't have an absolute value that's negative. The only time it's going to be less than or equal to 0 is when it is equal to 0. It can't be less than. Cannot be less than. Can only be equal to. And when it's equal to 0, there is no plus or minus 0. The only number that will solve this inequality is -2. That's it. All right, there you go. That is 8.3.